So now we are on our way to the library for our discussion.
Here I want to explain about Napier. Who is Napier? Napier is a Scottish scholar who is best known for his invention of logarithm. He also had a great interest in astronomy, which led to his contribution to mathematics. His first math discovery known in 1614 in his book called A Description of the Wonderful Canon of Logarithm. He had 2 wives and 10 children. He died on 4 April 1617.
I will be briefly explain about the Napier bond. So the Napier bond is actually used to multiplication, division, and also square root. We take 27 as example, and we try to use the number 2 as multiplication, also division. Actually, Napier bond uses the tens and also the regular value. 2 times 2 is equal to 4, right? So we write 0/4, where 0 is a tenth value and 4 is a regular value. The same goes to 7. 7 means 7 times 2 is 14. So the 1 as a tenth value and also 4 as a regular value. So from this we can get answer is 54, where 5 comes from these two. We have to add both of the number, and the 4 is just a regular number. So from this example we can say that when 54 is divided by 2, we can this equal to 27.
Hi, my name is Ashraf and I'm going to talk about one of the Napier's logarithm application, which is interest compounded annually. So from the question we know that ST is equals to 20,000 times 1.05 in the power of t, which is also equal to 40,000, which we want to find out. First we divide it by 20,000 and we will get 1.05 in the power of t, which is equals to 2. We apply log of 10 to the both equation and we will get like this. From the equation we can bring the t in front, we can bring the log 10 1.05 to the other side, so we will get in the form of t. So t is equals to log 10 in the power of 2 over log 10 in the power of 1.05, and using the calculator we will get the value 0.30103 over 0.02119, and then we will get it is equals to 14.20623, which is approximately 14 years.
Now let's move on to the properties of exponent. This is all the properties of exponent that we have learned in class. This all, and it makes our calculation easier. Let's move on to the properties of logarithm. The first one, as we know, this is the product. The second one is the quotient, and the third one is the power, and the last one is, we know that the log base is the same, so we can conclude that m is equal to n. Okay, the last one is about the graph. This is the graph for exponents, and this is the graph for logarithm. So from this graph, the third graph, we can conclude that the graph of logarithm and exponent are inverse functions. So note that log x is equal to log x base e. So we can say that the properties of log x is same as logarithm, and exponent as same as ex.
About the applications of logarithms, we have different applications like the decibel of sound to measure the magnitude of earthquake, the brightness of stars, population growth, pH value, compound interest, radioactive decay, and carbon dating. Here are the different equations for the different applications. As you can see, all of these have logarithm function in their equation. For the last two, we have exponential, so we can use ln x and logarithm to simplify our calculation.